Good afternoon, ladies and gentlemen. Your host, Golden Zulu. So today we have been faced with one interesting question, which reads to say, consider the population variance. Remember, variance is also referred to as sigma squared. So we have been told to say that we should show that this formula is equal to this formula, which is here. So remember that this is a complex equation and this is a simplified equation. So we will copy the way the equation is. So the summation of n I is equal to 1 x1 minus mu, this is mu squared over n. So we have been told to say that we should show that this is equal to that equation there. So what we will do here is we will first expand this and simplify. So let us expand and simplify. So for us to expand, we'll have to just copy this the way it is. Then we know to say we have x1 minus mu, x1 minus mu as well, over n. So what we'll do now here is we will distribute this to what is inside. We'll have, let's just copy it from a side here. So we'll have the summation of n I1. So this times that is x1 squared. This times that is negative x1 mu. Then this times this is x1 mu, and mu times mu is positive mu squared over n. So this is what we have when we multiply. Then from here now we'll simplify and we'll have the summation of n I is equal to 1, where we know to say x1 mu minus x1 mu is equal to negative 2xi mu. So we'll have x squared I minus 2xi mu plus mu squared, like this. We divide this by n. Then from here now we will distribute the summation to what is inside, and immediately we distribute the summation to what is inside, we will have the summation of I1, which will be that. Remember, we are just distributing it to what is inside. So we have this 2xi mu plus n, the summation of I is equal to 1 mu squared, like this. So we can just remove the bracket. It has no use now, over n. Then immediately now we have this. We should always note one thing. So remember, mu is like mean, and mean, when we are to calculate it, it doesn't change. We can use mean to calculate the mean absolute deviation. Mean doesn't change. So from here we'll factorize this mu. So we'll have n, the summation of I is equal to 1 x squared I minus, so what will not change, we'll factorize it. 2 will not change, so 2 will come outside. The summation of I is equal to 1. Then also mu does not change, so let mu as well to be outside. And we know to say even here mu does not change, so let us bring mu outside, and you will remain with 1 here over n. So we have some things to note when we are dealing with making a complex equation to become something that is short. We have something that we should always note. We should always note that the summation of n I is equal to 1 xi is the same as mu multiplied by n. And we should note to say the summation of I is equal to 1 is equal to n. So these are the equations that we have. So we should always note these these are two equations we should always note when we are dealing with making a complex equation to something that is not complex. So now that we have this information, we will now replace this which we have remained with. Remember here we have remained with xi. Sorry that we did not write it. So we have now remained with this. So let us just copy this the way it is. I is equal to 1 x squared I minus 2 mu, where remember n, the summation of 1 is I is equal to 1 is here, which this is the same as mu n. So we'll say multiplied by mu n plus, where this which is here is the same as n. Remember, this is the same as what is here, so we have mu squared n, where we divide this by n. Now that we have that information which is there, let us just continue on somewhere separate. So let us just continue on this clean sheet. So let us just continue here. So we know to say mu times mu. So let us just say the summation of n I is equal to 1 x squared I minus mu times mu is 2 mu squared n plus mu squared n over n. Then now that we have that, we know to say these two are like terms and they can subtract, and we'll have the summation of I is equal to 1 x squared I. Even when you subtract here, the answer you get is mu squared n over n. So when you check the equation that you have made and get the equation that they wanted you to make, you will realize to say that these equations are the same. So this is how you derive this equation to be this equation which you were given here. Your host, Golden Zulu.